In this lesson, we're going to review the properties of the special right triangles. For some of you, this may be new material if you didn't learn it in your geometry class. For others of you, this might be review, but in pre-calculus, it's important to remember these properties because they are used as we progress through our trigonometry unit. So the 45-45-90 triangle theorem is here on the slide in front of you. You can read that. I'm not going to read the slides to you. But the basic idea here is that when you have a 45-45-90 triangle, because the two angles, 45 and 45, are the same, then the sides opposite from them are the same. That's where you get the L and the L from. I'm going to erase that out of there. It's a little messy. Then when you go to get the hypotenuse, and as we know, the hypotenuse is the longest side in a triangle, we multiply the length of L times the square root of 2. So this is the general property. It's kind of like a definition that you can remember. Take a look at an example. Here we have an example with a 90-degree angle right here, a 45-degree angle, and I think it's safe to assume that we at this point know that this is also 45 degrees because the degrees in a triangle add up to 180. That would make that 45 degrees. So when we look at this particular triangle, you're going to see that this side along the horizontal and this side along the vertical are going to be the L's from the previous slide. And they're both going to be the same amount. So if this one is 9, then this one is 9, and this one is 9 times the square root of 2. Now this is just a little explanation of that, explaining why it's a 45-45-90, and this is working out the solution for you. And that's how we do that. That's actually the most simple example of a 45-45-90. Here again, we have the two sides that are the same. So this side, I'm going to put little congruence markings here, and this side are the same length. That means that this is a 45-45-90 because it would mean that these angles would need to be identical since the two sides are identical. So they would both be 45. Just going to get rid of those markings so they don't confuse things. So since this is a 45-45-90, put our 45. Remember that our hypotenuse is L times the square root of 2. Well, our L here, these are both L's, are 6 square roots of 2 times the square root of 2. Now that's nice, but it's not simplified. So we can say 6 times the square root of 4, because 2 times 2 under the radical is 4 under the radical. And we all know the square root of 4 is 2. So that makes the hypotenuse 12. X is 12. What the PowerPoint's going to do right now is it's going to show you the solution on the next slide. It's multiplying that 6 square roots of 2 times the square root of 2 and getting 12. Not too bad. Here's a practice one. I'll pause for just a minute. See if you can figure out which the correct answer is. Since this is 7, this is going to be 7 square roots of 2 and 7, but they really want to know this piece. So I would pick C. Oh, so nice. Another example, give you a minute to try working that out. Gonna work mine over here on the right. I got C again. See how we did. Okay. Moving on. Now you have a different situation. Now you have a situation with a 45, 45, 90 triangle where you're required to get the L. You are given L square roots of 2. You have the hypotenuse. So instead of multiplying by the square root of 2 to go from L to the hypotenuse, you would do the reverse, or you would divide. So you would do 8 divided by the square root of 2. And for many of you, that's going to look uncomfortable because the radical is in the denominator. So that is unrationalized. So we rationalize the denominator by multiplying by 1 by the square root of 2 over the square root of 2. Which is 8 square roots of 2 over 2, or 4, because 8 divided by 2 is 4 square roots of 2. So you just have to remember that instead of multiplying by the square root of 2 to get the hypotenuse, you divide by the square root of 2 when you have the hypotenuse. And they're going to go through the solution here a little bit. They're going to set 8 equal to, I guess they're going to call it A times the square root of 2, whatever variable you prefer. They're dividing, they're rationalizing, and they're multiplying and simplifying. One more example with the hypotenuse. Remember, if we have the hypotenuse, we're dividing by the square root of 2, and then we rationalize. Which should be hopefully A. Woohoo! Yay, yay.